we will solve log equations. Now, we will use any of the properties of logs to solve these, and we have to make sure to exclude values that create log of a negative number, because remember, the domain goes from 0 to infinity. So if we get a log that is a negative number, it will be invalid. So if we go log -3, then it's a not real answer. So your calculator won't even figure that. Okay, so going back to the properties of logs, again, the first 4 are your basic properties, and then your last 4 are your quotient, or your product, quotient, power, and then solving for logs. So we will do several different things. It's kind of hard to teach on which one to use and why. You just have to look at what you have and see what you can do with them. Okay, so essentially the only thing I could tell you, or advice I'd tell you, is either get it to where you can have log equals log so you can drop them, or so that you have like a log base b x equals y, so that you can convert it over to a convert it over to an exponent, and hopefully you can solve using the exponents that we have solved before. So here are the properties of logs again, and we're going to use a random, it's going to feel random which ones to use. So the first one, log 3x plus 2 minus log 2x minus 3 equals 0. So since we have two logs that are being subtracted from each other, and they equal 0, we can actually set this up as log equaling a log, and that's what the first thing I would try to find to do is, can I set this so it's a log equals a log? Because then you can drop the logs and solve for the remaining. So x equals -5. Plug -5 in, so we get 3 times -5, which is -15 plus 2. Well, that's going to be a negative value. So that won't work. So this is actually a no solution. Because if we plug -5 in, even here we get a -13. Well, that just actually will not work. So the first one ends up being no solution. Okay, the next one, log x plus log x minus 3 equals 1. Now, we can't just subtract a log over and drop the logs, because we would still have to add a 1 to the log. But we see here, bases are the same. We can actually multiply those together. So we have a log equaling a number. So remember, if there's not a number here, this is base 10. So we have 10 to the first power equals x times x minus 3. Okay, so if you cannot drop the logs, the next best thing is to see if you can convert a log over to exponential, meaning that you must have one log on one side equaling some number. So this will be 10 equals x squared minus 3x. Quadratic, so we have to make sure everything is on one side, and then we are going to factor -5 plus 2, so x equals 5 and -2. So now we need to go back up here. Right away, the -2 will not work, and then the 5 will work, because we'll have a 2 here and a 5 here. So 2 will not work, so the only answer is 5. Okay, so the first thing is to see if you can drop the logs. Well, we can't drop the logs yet because we have a coefficient. But remember, The power rule says if you have a coefficient out in front of the log, you can upgrade it to a coefficient, or upgrade it to a power, an exponent. Now our logs are our bases are the same on our logs. We can drop them and solve. So I'm going to move everything over and then factor. So that would be a -2 and a -3. So x equals 2 and 3. So if we plug that in, it works for here, it works for here. So both of those are actually our answer. Let's see here, log x minus 90 equals 3 minus log x. Now on this one, we cannot just drop the logs because this side is not completely with a log. It's not a log with everything. So we must add the log over, and when we do that, oops, that's minus 90, plus log x equals 3, we can condense this, and that's why we took some time to learn how to condense. And then we can say, well, that's 10 to the third power equals x times x minus 90. So we have 1,000 equals x squared minus 90x. Solve for the quadratic, minus 1,000. So that would be x minus 100 times x minus 10. 100 times 10 is 1,000. Oh, actually that would be a plus. So there we go. And then add those, you get -90. So x equals 100 and -10. 100 and x equals -10. So if you go back up here, -10 will not work, but 100 will. So I'm just looking at the negative or positive of this. So negative and a negative, that's going to give us negative, but right away plug in that -10 in for the first one, and you are doomed. So x will have to only equal 100. Log base 9 equals log base 9. Okay, again, log base 9s, drop them. So these are pretty simple. When you drop them, I'm going to move everything over to one side, plus that would be 28. And then if we, oops, let's see here, that would have to be a +4 and a +7. So x has to be -7 and -4. So if we plug that in, negative times a negative will give us a positive, so that's good. Square a negative, we get positive, so both answers will work. So don't assume if your answer is negative, you have to nix it. You have to plug it back in to see if your value of your log will be positive. That's what we're testing for. Let's see here. -2 log base 5 x7 equals 2. Again, this one we don't need to log both sides, or we cannot drop the logs, but we can bring that coefficient up as a power. And then we have 5 to the second power equals 7x to the -2nd. Okay, 5 squared. So we get 25 equals 1 over 49x squared. And then we can, this is a proportion, so 25 times 49x squared equals 1. That is a large number. 25 times 49, oops, 1225x squared equals 1. Divide by this, x squared equals 1 over 1225. And I think, yeah, I think 35 times 35 is that. Yes. So if we square root both sides, we get x equals plus or minus 1 over 35, because if you square root both of those values, you get 1 over 35. Now, plug -135 in, you get a negative here. So x has to be the positive 1 over 35. Okay, because 7 times a negative value, it doesn't matter, it's still going to be a negative value. So the positive will have to work on that one. Okay, one more and then I'll cut the video. Okay, so this one, ooh, goodness. So we have lots of things going on. We have only one x, lots of logs going on, but if you can see, we have no x's in here. So these are just numbers, especially this one. So if we keep log 9, base 9, minus, or log base 9 negative 3x, excuse me, and we add this over, so log base 9, 35 plus log base 9, 3, use the product property, 35 times 3, which 35 times 3 is 105. So this is 105. And look, we can drop the logs. So it's really important to know how to condense your values or your logs. So this would actually be negative 35. So if we plug that in here, negative times a negative will give us a positive. So negative 35 will be your answer. Okay, so that is all I have for you with solving log equations.